Hello everyone, this is Neil from Edureka and welcome to this session on R programming. Now let's not waste any time and let's move forward and look at today's agenda and get a good understanding as to what we'll be learning in today's session. Now we'll start off by a simple understanding of what a variable is and the various data types that are supported in R. From there forward, we'll be looking at the various data operators, the conditional statements, the loops, and then we'll be slightly deep diving into strings and functions. Now, this is a completely practical session, but we will be looking at some of the theoretical part as well. So I hope you guys are definitely looking forward to today's session. Can you give me a quick confirmation in the chat box? Okay, so I've got a confirmation from Jude, Ajay, Sweta, Charlie, Terry, Aditya, Benjamin. That's great to see, guys. Okay, Benjamin is asking me what do I do in case if you have a doubt. Okay, this is something that I want to clear out in the start of the session itself. At any point, if you're not clear with respect to any concepts that we discuss as part of this session, or there's some place that you're getting stuck in, then please let me know. Just put across your problem in the chat box and I'll be able to assist you right away. So make sure at any point if there's something that you want me to repeat as well, that you let me know. Does that answer your question, Benjamin? Okay, that's great to see. So let's move forward and first begin by installing R on our system. Now to do that, you just need to go to the CRAN website and download R. Let me just show you how to do that. So you can open Google and search for download R. So you can go on to the first link and you'll get the direct link to download R for Windows base. So CRAN basically stands for Comprehensive R Archive Network. So they extensively work on development with respect to R. So you can either go download it from the first link, or let's say if you're using a different version, that is a Linux or Mac as your operating system, then you can go on to their website cran.r-project.org and then you can download the corresponding version as well. Now for Windows, in case if you are on this page, make sure you're downloading the base version and not any other version. So we have 4 different versions here, so just download the base version here. Okay, so just click on the link, go ahead and download it onto your system, and the installation is quite easy. You just need to click on next, and once you've completed your installations, please let me know so that we can move ahead. Okay, so now that all of you have successfully downloaded and installed R on your system, there's another tool that I want you to download and install, that is the RStudio. Now the purpose of installing RStudio onto a system is to help you have an IDE that will make it easier for you to program and work with R. So to download RStudio, just go back to your browser. Let's go to our trusted friend Google and search for RStudio download. So just click on the first link here again and you'll be redirected to this page. So there are basically 4 versions of RStudio. I would recommend that you go ahead and download the desktop version of RStudio, which is free. So just click on download here and you get the complete list of RStudio versions. Now you can choose the version that suits your operating system and then go ahead and download and install it. So again, this is a quite straightforward installation. You just need to keep clicking on next. So please go ahead and install RStudio as well on your system so that we can move ahead while you guys are simultaneously trying out the code when I'm explaining it. So please go ahead and download and install RStudio. Okay, so this is how your RStudio looks like, but let's keep it aside for now and we'll come back to our presentation where we'll start off with some basic knowledge with respect to R before we actually deep dive into it. Now the first concept that we'll be talking about is what exactly is a variable. Now before we actually move into the slides, I just want to have a simple understanding of how many of you are familiar with the term of variable, or how many of you are actually aware of what exactly is a variable from your understanding of different programming languages. Okay, so I've got a variety of answers here from most of you. Some of you are saying it's a value that you're using, some of you are telling it's a value stored in a memory location. Okay, there seems to be some lack of clarity here. Let's move forward and actually understand what exactly is a variable. Now, a variable basically is nothing more than a reserved memory location to store your value. Basically what it means is every time you need a variable in your program, then what happens is you're going to create the variable. At the time of execution, it identifies that this variable is of this data type and correspondingly a memory location is allocated for each variable accordingly. So again, it is a value that is being stored in a specific location. Is that clear? Okay, so let's look at the image below here. Now basically you're taking three different kinds of variables. One is actually a numerical value, the second is a string, and the third is actually a Boolean kind of value. Now don't worry about what exactly these data types are. Here it's just to help you understand how when you're using a variable, correspondingly a block of memory is allocated to it. Based on the data type, the size of the block slightly varies, but again, each variable gets its own memory location allocated for it. So now comes the most obvious question as to what exactly is a data type in R. Now, talking about the data type basically helps you classify the value stored in a variable. Now, why do we need to classify this is basically to help you perform different kinds of operations. Now, let's say it's a numerical value. Then you can go ahead and perform various arithmetic operations, you can perform various logical operations, relational operations, but you cannot do the same when it's a character value. That time there is no correct sequence or a correct way to perform arithmetic operations between two characters. Now, this is the exact reason why we need to classify the variables based on their different data types. Now, if you take a look at the image below here, you can see although we're creating three different variables, they each have a different data type that they belong. Now, let's say x is equal to 15. Now, this can be considered to be an integer type, but when you say y is equal to 3.142857, this is considered to be a numerical value. And finally, when you say b is equal to true, then this is again being classified as a Boolean variable. Now, how many different data types are present in R and how are they different? Let's move forward and try to understand them as well. Now, there are basically 5 different data types present in R. You have vectors, you have matrices, arrays, lists, and data frames. So let's move forward and discuss each one of them one by one. Now we'll start off by understanding vectors as first. Now a vector is basically a collection of different data elements that belong to an atomic type. Again, what is an atomic type? You have 5 basic atomic types present, or as they're better known, the 5 classes of vectors. The first is logical. Now, logical data type can either take a value of true or false. And then you have integers. Now, integer takes a whole number value, whereas numerical data types take both whole number as well as decimal part to it. Apart from that, you have complex variable and you have a character variable as well, wherein you can store a single character or a sequences of words as well. So are you clear with respect to these 5 atomic types? Okay, now when we talk about a vector as a whole, either you can have a single element belonging to one of these data types, or it could be a sequence of elements as well. Both of them are a vector. So let me go to the RStudio and show you these 5 data types as well as how you can work with vectors. So we have our RStudio here. Now just to give you a simple introduction, this is basically your R scripting area. So the scripting workspace is something that you can use when you need to write multiple lines of code. And let's say if you want to execute a single line of code, then you can use the console area as well. Now every time you declare and work with a variable, it gets automatically updated into the environment area. And let's say if you want to install various packages, work with different packages, or you're not clear with something, then you can use this workspace to get a better understanding and have a clearer image. Now again, even if you plot a graph, this is the workspace where you can see it as well. For now, let's try to understand the different atomic classes of vector. So to command anything in R, you can use the hash symbol. So first we're talking about vectors. Let's begin by looking at logical data types. Now again, to create a vector, you just need to specify the name of the vector. So I'm going to call it VTR1. Then you can use equal to, and then use C and inside quotes. Now inside quotes you can pass any value that you want. Now a logical value can always be true or it can be false. Now always remember, true and false need to be capital always. Now if you want to just execute it, let's select the statement and you can go to run, or if you have multiple statements that you want to execute at once, then you can go to click on source. This will directly completely execute the whole code written in the script page. Now I just need to execute this single line, so I'll just click on run and a new variable has been created. So if you see here, a new variable has been created of logical data type and it stores 2 values, it's true and false. But how do you know which class it belongs to? To always know to which data type a vector actually belongs to, you have a simple command, that is class, and then you just need to pass the variable's name. So in this case, let's say VTR1. I'll just select the statement again and let me just run it and show it to you. So here you can see the output in the console area. It says the class which vector1 or the data type to which vector1 belongs to is logical. So here again you can see there are two values that I'm passing to vector1. Now let's say I'm going to create vector2 as well. Okay, here I'll just pass a simple numerical value. Let me say C of 15, 85.674954, and then I'm going to even pass 999999. Okay, so I'll just select this and run it. So a new vector has been created. You can see that in my environment workspace. Now if you want to see the value stored inside a specific variable, all you need to do is specify the name of that variable. Now you can do that in your script workspace. So if you write it directly into your console, then you can see the corresponding value as well. Now if you look at the format here, the value for each of these have been changed. This is mainly because the range of numerical value that it can store. A numerical value that is greater than 7 digits will always be converted to the exponential format. Now, since a specific value in that vector, that is 99999, is greater than the range of numerical value, all the values present in that vector are being converted to the exponential value. So this is something that you can always remember. But let's say I'm going to reduce this value here. Now if I just update and run this, then you can see the value present here. 15 was a whole number which did not have a decimal pointed value. But since 85 had a decimal pointed value, everything gets changed. So always all the values are checked in the vector and only then are they stored. So are you clear with respect to logical and numerical data type? Okay. So Jude is asking me, how is integer type different from numerical type? That's a very good question, Jude. Now again, this comes back to the same point that I had discussed earlier. Integers cannot store a value that has a decimal point associated with it. So to store decimal point value, you have the numerical data type. So let me just show you integer as well. Vector3 is equal to C of, let's say you want to store 35. Now if you just pass 35, then what happens is this gets treated as a numerical value. But with this value, if I just pass a capital L, then it will treat it as an integer value. 35, 54, 58 and 146. So always when I'm passing L along with the numerical value, it treats it to be an integer. So let's say I want to print out numerical value vector3. So you have all the values and I'll say class of vector3, then it's telling me the value is integer. Now coming back to your question, let me just create a new vector, vector4, to which I'll assign C of 58.465 and I'll put an L along with this. As I had mentioned earlier, if you pass L along with a numerical value, it treats it as an integer. But what happens if you pass L along with a decimal pointed value? I'll just show you that. So here you can see when the compiler is trying to execute this code, you can see a warning message has been passed saying that the integer literal 58.465L contains a decimal point, and it's suggesting me to use a numerical value rather than an integer. So are you clear, Jude? Okay, that's great to see. Okay, there's another question from Charlie. Charlie is asking me what happens if I try to store different data types in a vector. Okay, that's a very good question, Charlie. Let me show you what happens. Let's say I'm going to create vector 5. Okay, equal to C. Here I'm going to pass true, which is a logical value. Then I'll pass an integer value, let's say 35. I'll even pass a decimal pointed value, let's say 3.14. So who can tell me what will happen if I execute this? Okay, let's see what happens. It gets created. But let's see what value is actually being stored in vector 5. So you can see here, it's considering the value true to be 1. and it is converting everything to decimal pointed value. Now I'm going to create a new vector, let me call it vector 6, where I'll even include a character string along with it. So C. Now again, any character string can be put into a single quote or a double quote. It treats both to be the same, and it's stored using a double quote in R. So let's say hello, then I'll pass logical value false. I'll say 65L. So basically this is a combination of character, it has logical value, and it has an integer value. Let's run this. And it gets created. Still there is no error that gets generated. But what happens when you try to print vector 6? So here if you can notice, everything is being stored but they are in double quotes. That means what happens is that every value that is being passed along with a character value is being considered to be a character. So hello is a character, false is a character, and 65L is a character. To get a better understanding, let's use the class function where I'm passing vector 5. Now, if you remember, vector 5 had logical value, it had integer value, and it had a numerical value. If you execute this, you can see it considers everything to be a numerical value. And in case if I check with respect to class of vector 6, then it's treating everything to be character. Even though there is a logical value and an integer value, it is considering all of it to be character. So again, in case if you are creating a vector that has different data types, then it actually converts all the variables having different data types to a common data type. So are you clear, Charlie? Okay, that's great. Okay, so now that we have talked about the 5 different classes of atomic vectors and we've seen vectors as well, let's move forward to the next data type, that is matrix. Now basically your matrix in R is quite similar to your arrays in other programming language. Now here you have arrays as a different data type itself, but you'll understand it better if you are able to relate it. To those of you who are not familiar with what exactly an array is with respect to programming language, an array or a matrix in this case is a two-dimensional rectangle layout. Basically, it's similar to an actual matrix that you're using in mathematics where you're storing different values in an orderly manner. Now, the syntax for declaring a matrix is quite straightforward. You specify the data type, that is matrix, followed by that you specify the data, the number of rows, number of columns. Now, by row basically is a logical clue that you say. So you actually use by row to order the input vectors in a specific manner, and your dim names basically are used to assign names for your rows and columns. So let's go back to our RStudio. Let me clear all this and let me show you how to create a matrix. Now first again, let's try to name our matrix. I'm going to call it mtr and then mtr equal to, now again as I had mentioned, you need to specify the data type. So it's of a matrix type. Now here you need to specify the data that needs to be stored inside a matrix. Now I can store a random value that is there, but what I'm going to do is I'm going to create a new vector, and this vector basically is going to have a sequence of number starting from 5 and going on till 30. So there are basically 25 elements. Okay, now when you say 5:30, that means I need to store a sequence of numbers starting from 5 with a constant increment of 1 going up till 30, that is 25 elements. Now my number of rows are 5, my number of columns are 5. Now I don't need to arrange them in certain way, nor do I need to specify the names of the rows and columns. So this is it. You can just go ahead and run it. So here you can see the problem. This says in a matrix of 5 cross 5, I cannot store 26 elements. That means it's greater than 5. So one thing would be is you can either reduce the value here to 29 or you can update the value here as well. So let me just reduce this and let me try rerunning this. So here you can see successfully it has been executed. So let me just show you how the value looks like. So again mtr and I'll just run it. So you can see below how a matrix is being stored here. So 5, 6, 7, 8, 9, 10 and correspondingly the sequence are being filled in a column manner. And this is quite similar to the matrix that you have seen in mathematics. So any doubts on how to work with matrix and how to create one, you can go ahead and try creating a matrix, and if you have any problems or any doubts, do let me know in the chat box. Okay, so I've got a confirmation from Benjamin, Terry, Aditya, Shweta, Charlie. That's great to see that you guys are following and trying it out simultaneously. Now that you've understood what a matrix is, it'll be easier for you to understand what exactly is array in R. Now, your array is quite similar to your matrix. Now, it can store the data in more than 2 dimensions. What do I mean by that is, so if you look at the example here, it'll be easier for you to understand. Not only are you creating a 4x4 matrix, but you're also storing it in a 2x2 matrix. So basically you're storing 64 elements, but they are again in turn being stored in 4 different 4x4 matrix. So your array in R is something that can store your data in more than 2 dimensions here. So I hope this example was something that had given you a simple idea on how an array is different from matrix and how it is in R. Okay, so let's go back to our RStudio and let's try it out. So let me go ahead and create an array called ARR. Then you need to specify the data type, that is array. Then comes the value that needs to be stored in the array. So I'm going to create a new vector starting from 1 to store till 9. Then comes the dimension of the array. Now to specify the dimensions, you need to use dim keyword. Then you need to use a vector. Now in your vector, the first 2 columns are going to specify the standard size of each matrix that is going to be stored in an array. So I'm going to store it in a 3x3 matrix. Then what I'm going to do is I'm going to store it in a 4x2 array. So I have a 3x3 matrix that is again in turn going to be stored in a 4x2 array. Okay, so let me just run this, and if you try to print array, I'll just enlarge this for your understanding. So here you can see the values. So this is my first matrix, this is my second matrix, this is my third matrix. Now all these 3 belong in the first row. So you have the corresponding column number and the row. Similarly, the 4th column of the first row also stores the same. Then you come down to the second row and you have 4 similar divisions. So are you clear with respect to how we work with an array and how to declare and view an array? Any doubts with respect to array? Okay, so Aditya has a good question here. Aditya is asking me what happens in case the number of values is less than the size of array. That's a very good question, Aditya. So here what I'll do is let me just change it to 6. So if you look at our first matrix, it's storing all the values 1 to 9 in the column fashion. Now I have only a range of starting from 1 going up till 6. Now with the same condition, let me just rerun this and I'll try to print array. So what you can see here, Aditya, is that if your array or matrix does not have enough values to fill the matrix or array completely, then what happens is it takes the same input vector and starts inserting elements from the start. Now I needed to store 9 elements in my vector, but I had only 6 values. So I've inserted the first 6 values column wise, then I've again started inserting the values from the start of the vector. So the first 3 values are stored in my first matrix, which is stored again in the first row and first column of the array. Then the corresponding next values have been stored in the next matrix, which is stored in the second column of the first row. Have you gotten an idea about this, Aditya? Is your question clear, Aditya? That's great. So any other questions? Alright, so let's move forward and talk about the next data type, that are list. Your lists are quite similar to your vectors itself, but the only key difference between your list and your vectors is that you can store elements that belong to different data types in list without actually changing their data types. Now we had seen this problem with vector where you was trying to store character value, logical value and a numerical value, and in turn they were getting changed to a character value, and in our first example, if you remember, we had tried to store logical value, an integer value and a numerical value, which in turn got converted to numerical value all around. So with respect to list, you can store the elements which belong to different data types and their data originality is stored. Now let me go ahead and show you how to do that. So let me clear this as well. Now let me begin by creating two vectors. So let's say VTR7 equal to C of, let's say I have numerical value, let's say 5.678, then I have 32, 95, 31.6, and I have another vector VTR8 which has character values. So hey, how are you, thank you. Okay, so I have these two vectors that need to be created. So just run this and they get created. Now what I'm going to do is I'm going to create a list, say call it my list, which is going to be of data type list. So again list, and here what I'm going to do is I'm going to pass vector 7 and vector 8. If you want, I can even pass vector 1 which has logical value, vector 1, and then let me just execute this command and they get updated. Now let's check what my list looks like. Now if you look at this, all the numerical values are being stored together. You have the character values and you have your logical values also being stored. None of these values are being converted to a common format and all of them are actually retaining their original data type. Now in case if you want to store different data types and retain their original data types, then you can go ahead and use lists. So are you clear with respect to lists? Any doubts? Okay. Now the last data type that we'll be talking about is a data frame. So basically a data frame is a table or a two-dimensional array-like structure that can actually store your data in an ordered manner. Now again, let's say you're working with a table that is stored in an Excel file or you're loading a table from a database, then you would be directly loading it into a data frame and then working around with it. Now let's go back to our RStudio and let's first try creating a new data frame, and then I'll also show you how you can work around with the data frames that are present in R. So let me just clear all this. I can also go ahead and clear the variables in my memory. So we'll begin by first creating three vectors from start. So my VTR1 is going to have, let's say, value starting from 1 and all the way up till 5. So 6 values there. Then vector 2 is going to have names. Let's say I'll start off with mine. I'll put in Jude. Let me bring in Adam as well. Aditya. Shweta. Okay, let's keep it just 5 names here. Okay, and along with this, let me create another vector. That's vector 3, and here what I'm going to store is, let me just store new random numerical values. So let's say 15, 25, 65, 145 and 74. Okay, so basically I have three vectors here. So let me run this and you can see three vectors have been created. Now what I'm going to do is I'm going to create a data frame. To create a data frame, you can use the syntax data dot frame and then pass the values that you want to be in your data frame. So I want my vector 1, vector 2 and vector 3. So just run this statement again and you can see your data frame present here. From my vector 1, 1 to 5 has been stored. Correspondingly to that, the first element from my vector 2, that is Neil, has been added, and the corresponding first value is being taken from the third vector and it is also being added. So each of the first element from the three vectors have combined together to form the first row of my data frame. So is this clear on how a data frame works? Okay, so let me show you how you can use a data frame of an inbuilt table. So just call for data frame. Now let's say I want air quality. Now air quality basically is a table that is already present in my RStudio. So if you just run this, you can see the complete table being stored as a data frame. So here again you have the ozone, you have solar ratio, you have the wind, temperature, month. So this is basically the quality of air measured over different time frames in a span of one day. So every day you're measuring these four quantities and then you're putting it as part of your table. So this is something that will give you a good understanding as to how to work with the data frame. Similarly, you can import a table, you can import an Excel file and then directly store it into your data frame as well. So we'll be seeing about that in our next class where we'll be working with the analytical section of that. But I hope you guys are clear with respect to what is a data frame and how you can work around with it. Can you give me a quick confirmation in the chat box? Okay, so I've got a confirmation from Aditya. Terry says clear, so does Jude, Sweta. That's great to see, guys. So now let's move forward to the next concept of today's session, that are operators in R. Now talking about operators, there are mainly four different operators. But what exactly is an operator? Operators are basically constructs which help you manipulate the actual value of each of the variables. So using an operator, you can perform various operations and change the value stored in each of the variables. Now again, as I had mentioned, there are mainly four different types of operators. You have arithmetic operator, you have relational operator, logical operator, and assignment operator. So let's move forward and look at each one of them one by one. Now talking about arithmetic operators, you have addition, subtraction, multiplication, division. Now these are some of the common operations. Now I'm quite sure that all of you would be familiar with this. Now again, if we come back here, let me clear all this. Let's say print 6 plus 9.87. Let's just run this. So basically you're getting your output. Similarly, if you want, you can change it to any other. You can say division. So it's giving you corresponding value and so forth. Now, apart from normal arithmetic operations of addition, subtraction and division, we have three new operators here. The first is modulo operator. Now, in our normal division, when we perform division, we get the result to be the quotient of that division. But in case of a modulo division, what happens is you get the remainder. Now, to specify that it is a modulo division, you just need to use two percentage symbols and it gets converted to a modulo division. If I run this, you can see the difference. Earlier it had given me a division, here it has given me the remainder. Now, let me give you a better example here. 22 divided by 7 gives me the value of pi. Now, I'm quite sure all of you are aware of it. Now, same thing, let me just change it to modulo division and I'll rerun this. Now, when I rerun this, you can see the output to be 1. Although a division is being performed here, but instead of the quotient like you normally get, you're getting the remainder. Are you clear with respect to what modulo division is? Okay, that's great. Now, apart from modulo division, you have your exponent operator. Basically, if you want to raise any variable to a power, then you can use the exponent operator. Let me say I want 2 power 7, then you can use the exponent operator and you can run and get the corresponding value. Now, finally, you have your floor division. Now, floor division is something that is quite interesting. What happens in floor division is that you divide a number, and if the quotient that you're getting as the result turns out to be a decimal number, then it is actually rounded off to the previous whole number. Now, to explain this to you, what I'll do is I'll just modify this. I'll make it again 22 floor divided by 7. Okay. Now we know that 22 divided by 7 actually gives us the value of 3.142857 and 22 modulo division 7 gives us the output of 1. But what happens in case of a floor division? You get the output to be 3. So what happens here is the value that you actually get is 3.142857. But since it is a floor division, it gets rounded off to the previous whole number, that is 3. So are you guys clear with respect to how a floor division works? Okay, Shweta has asked me what if the decimal point value is greater than 5. Okay, Shweta, that's a very good question. So let's try something out. Let's say 3.9, okay, floor divided by 2. What is the answer for this? Yeah, it's 1.95. So if I run this, you can see the value to be 1. Even if it is 0.99999, it still gets converted to the previous whole number. So does that answer your question, Sweta? Alright. So apart from your arithmetic operations, you have relational operators. Now, relational operators are usually used to compare the actual values of two variables, and then the output that you get is actually a Boolean value. Let's say you have two variables A and B. Now, if you want to know which is greater out of the two, then you need to use the relational operator greater, and you can check if A is greater than B. If A is greater than B, then it returns an output to be true. If it is not, it returns an output to be false. Similarly, you can have less than. Now, apart from your greater than and less than, you also can check if a corresponding value of a variable is equal to or greater than or less than. That is, if you look at the operator here, let's say you want to check if A is either greater than or equal to B, then you can use the greater than symbol followed by an equal to. And let's say if you want to compare the value of two variables, then you need to use double equal to, and only then will it compare. If you use a single equal to, it becomes assignment. And for checking if it is not equal to, you can use not equal to. Let's come back. Let's say var equal to 25 and var 1 equal to 60. Now let me print var greater than var 1. If you run this, the output is false. No, the value of your variable var is not greater than variable var 1. But let's say if I'm checking if they are equal to as well. So again, double equal to, and if you run this, it says false. Are they not equal to each other? So for that, an exclamation mark followed by equal to gives you the output to be true. That means the value of variable is not equal to variable 1. Are you clear with respect to the relational operators? Okay, so Ajay has asked me, where do we normally use relational operators? So that's really a good question, Ajay. You will be using relational operators and logical operators that you'll be seeing next as part of your conditional statements. Now, what are conditional statements? I request you to be a bit patient because we'll be discussing that in the upcoming slides. And if you're not clear at that point, then we can come back and answer your question all over again. Is that okay, Ajay? Okay, that's great. So moving forward from relational operators, you have assignment operators. Now again, assignment operators are of two types. So till here you have seen how I have created variables and assigned them using the equal to. Apart from that, you can always use the lesser than symbol followed by a hyphen. Now this also means that you are assigning a value to a variable, and this can also be done as per left assignment and right assignment. So what this basically means is that you can either write the name of the variable to the left, the assignment operator, and then the value to the right, or you can also write the value to the left following the assignment operator and the name of the variable. So both of this is accepted, and you can use an equal to or the lesser than followed by hyphen symbol to assign the value to a variable. Are you guys clear? Okay. So after the assignment operator comes your logical operator. Now there are basically three logical operators that we'll be discussing. You have your logical AND, logical OR, and NOT operator. What does your logical AND do is that it actually checks the value of both the variables, and then it gives you a corresponding output. Now you get the output to be true only and only if both values are true. In case one of them is false, then the output is considered to be false in case of your logical AND. But in case of your logical OR, at least if one value is to be true, then the corresponding output would be true. Now I'm quite sure that most of you would be confused. So what I'll do is, let's go back to our RStudio. I'll clear all this. I'll create two values, value 1, which is again a vector having true and false, true and false. I'll also create another vector, value 2, that will have value false, then true, true again, and finally false. Now what we're going to do is, let's see the output for this. Print value 1 and value 2. So let's execute this code now. So here you can see when I'm trying to check, the only case the output is coming to be true is when both the values are being true. So each value is being checked with the corresponding value from the second vector, and it is deciding if both values are true. Only in that case is it printing out a value to be true. But let's say in case of an OR operator. Let's just run this and see. So in that case, only where you're dealing with two false statements is the output considered to be false. All other cases are coming out to be true. Apart from this, you also have your logical OR, wherein if I execute this and see, then only the first values present between both vectors are checked and the corresponding value is decided. So if I'm using a single AND or a single OR, it is an element wise AND or an element wise OR. But if I'm using double or double AND, then it is a logical AND operation or a logical OR operation. So here you can see where I'm using a logical AND operation, then it is checking the first two values, and since both values are not equal to true, it is giving me the output of false. So any doubts with respect to the logical operators? Oh yes, we missed out on one operator, that is the NOT operator. Now NOT operator is quite straightforward. Let's say NOT of value 1, then all the values have been reversed. Where I had true as the first value in my value 1, it is getting replaced to false. Where it was false, it is getting changed to true. So any doubts with respect to the logical operators? So this is the element wise AND, element wise OR. We've seen the logical AND, logical OR, and finally we've also seen NOT operator. Okay, so I've got a confirmation from Charlie, Ajay, Aditya, Terry. That's great to see, guys, that you're following. So please make sure you're simultaneously trying out these codes as well so that you'll have a complete understanding. So moving forward, let's look at the conditional statements, and this should answer your question as to where we're using relational operators and logical operators. Now, talking about your conditional statements, there are mainly three types of conditional statements that we'll be dealing with, and an extension of a conditional statement. So basically there are four different conditional statements that we will be using. Now the first conditional statement that we'll be looking at is the if statement. Now what your if statement basically does is that it checks a specific condition, and if the condition is found to be true, then it goes on to execute a set of statements, but if it is not, it will ignore these complete set of statements and move forward. Now how does this work? Let's go back to our RStudio. Let me clear all this. Let's say var 1 equal to 25, var 2 equal to 35. Now I'm going to use the if statement. If var 1 plus var 2 is greater than 50. So you can see here I'm using a relational operator along with the conditional statement as well. So coming back to your question, this is where we completely use relational operators, as well as you'll also be seeing logical operators in the upcoming slides. Now in case if they are greater, then I'm going to say print. Now if you want to print a string, put it in quotes. Value is greater than 50. You can select all this, and if you click on run, it says value is greater than 50. But let's say I make it 100. Now if I just run this segment of the code, then it does not print anything. That basically means that the statement written inside the if condition gets ignored. Are you guys clear with respect to how the if statement works? Okay, so I've got a confirmation from everyone. That's good to see. But let's say you have more than one condition that needs to be checked. What do you do in that case? In that case, you can actually use an else if statement. Now else if statement basically can be used for helping you to check multiple statements and check their corresponding validity. Let me just show you how to use the else if statement as well. Now first, if condition is checked, then let's say else if var 1 plus var 2 is greater than. Now it's checked the first condition whether it is greater than 100 or not. If it is not found to be true, only then will it come to else if condition. Let's say 75 in this case. Then I'll just copy the statement. Value is greater than 75. Let's say you want to add even one more condition to this. Then just copy this else if. Let's say 65 in this case. So again, you can see here we are putting multiple statements here, and their order of checking or the order of evaluation is in a sequential manner. First, it will check if it is greater than 100. If it is found to be false, it will go into the next condition. It will check if it is greater than 75. If it is false, then it will come down to the third condition and see if it is greater than 65. I'll select all this and let's run it. So none of these three statements have been executed. So it's checked all these three statements and it's found to be false. Finally, let me just write one more condition, else if. I'll copy this completely. And here I'll just change it back to 50. Now we know this value is greater than 50. And I'll update it inside as well. Now let's execute this and see again. So here finally it is evaluating all these three conditions before it, and finally it's found a match, and that's why we are getting the output. So are you guys clear with respect to how the else if condition works? Yes, Shweta, that's a very good question. So Shweta has asked me, is there any limitations on number of else if I can write? Not at all. You can write any number of conditions. But rather than writing multiple conditions that you want to check, what you can do is you can make use of logical operators and then evaluate these expressions. Okay, so that's great to see that all of you understood the if and the else if part. But let's say if none of your condition meets, then what do you do? And in such cases, you can always go ahead and use the else statement. Now, your else statement is a conditional statement that definitely gets executed if no other condition is met. Now, if you go back to our studio, let me just remove this condition, the final condition, and let me just put in an else statement here. Else, I'll say print number is less than 65. Okay, let's try executing this. So here you can see all these conditions were checked, and since none of them were found to be true, then you go into the else part and the statement written inside else gets executed. So this is same that has been diagrammatically represented here. Let me just give you a simple explanation here. So if you see, always we start, the first thing that you do is check the if condition. If it is found, then you execute the if part. If it is false, then you go to the else if conditions. Each of the else if conditions is validated, and whichever condition is found to be true, then the corresponding else if code gets executed. If none of the else if conditions are also found to be true, then you go to the else part and execute the else code and finally come out from the selection section. So are you guys clear with respect to the if, the else if and the else statement? Now please make sure you're quite clear with this, because this is a very strong fundamental concept and is one of the very important concepts that you need to be aware of with respect to any programming language, not just R. Okay, so I've got a confirmation from everyone. Now the fourth conditional statement that we'll be talking about is the switch case statement. Now in case of the switch case statement, basically what you're doing is you're already aware of the value that the expression is going to take. Now once you know that, then in such cases you can go ahead and write a specific statement. Now how does it vary from if else statement? Now the major thing there is the knowledge of the value that the expression takes. Now you cannot use an uncertain value or a range like you have done with the if else statements. Here you need to specify the actual value that the expression can take, and then you can specify the corresponding statements. Now what I'll do is, let's go back to our RStudio. Let me just clear all this. Let's take a simple example. Let's say switch. With respect to expression, I'm just going to give you a value of 4. And then let's say in case the value is equal to 1, then print Monday. So I hope you guys get what I'm trying to do. For the number value that it could take, I'm specifying which day it is going to be equal to. Print Tuesday, Wednesday, Thursday, 5 is equal to Friday, 6 is Saturday, finally 7 is equal to Sunday.
Okay, so before I go ahead and execute it, let me just make certain small modifications with respect to this. I'll put the values in quotes. Basically, it makes it easier for the evaluation to take place. Now I'll just execute it, and you can see the value is being printed as Thursday. So what has it done? It has first checked the value of expression, then gone to check on the various value that the case can take. Once it's found a match, then it has gone ahead and executed the statement associated to that case. And always make sure you put comma after you've completed the statement for each case, because this is how it differentiates that the next case is about to start. Now in case if there is no match, then we can use a default statement. That case what I'll do is I'll just write print invalid input. So now that I have specified the default value, let me go ahead and change this value. Let's say it's going to take percentage as a special character. So it does not meet any of the cases. If you try rerunning this, then what happens is you get the output as invalid input. That is, again, as you remember, we had done with else case. If no other condition meets, then the else code is written. Here, if no other case matches, then you reach the default statement. So any doubts with respect to the switch case statement or the if else statement, any of the control statements that we have discussed till here? Okay, so I've got a confirmation from Jude, Shweta, Ajay, Aditya. That's great to see. So moving forward, let's talk about the next statement, that are loop statements. Talking about the purpose of loops in R, it basically is quite similar to any other programming language. The main objective is to help you execute a group of statements multiple number of times rather than rewriting them multiple times. So this in turn goes on to reduce the code redundancy and also makes the performance of the program better. Now, talking about the different kinds of loops in R, you have mainly three kinds of loops. The first is repeat loop, the second is while, and the third is for. Now, although these three perform the same operation, that they help you execute the statement multiple number of times, but how they do that is slightly different with respect to each of them. So let's go forward and try to understand each one of them one by one, starting from the repeat loop. Now, the repeat loop basically helps you execute a group of statements any number of times until the condition that you have specified inside it turns false. And this condition is always checked after the statement is executed. Now, talking about the flow of a repeat loop statement, you always start with the execution, then you go on to execute the code block, and then you check the condition. If the condition is found to be true, then you exit from that loop, and if it is false, you go on to execute the loop n number of times until the condition is found to be true. Okay, so let's go back to our RStudio and try this out. Let me clear all this. So let's begin by first creating a new variable. Let's say variable var1, okay, which is equal to 5. Then what I'll do is I'll use the repeat loop. Now here, let's say I want to print every odd number starting from 5 till 21. So in that case, what I'll need to do first is print the variable 1 to know the current value. So var1, then I need to update the value of variable 1. So var1, I need to make sure it achieves odd numbers only. So var1 is equal to var1 plus 2. Now I need to define the condition which will help me leave from this loop. So in that case, let's say if my var1 is greater than 21, then you need to break from here. So break. So are you guys clear with this? As to the logic of the repeat loop, I'll just explain it once again. So we've started by declaring a variable equal to 5. Then we have printed the current value of the variable. We have appended it, and if it crosses 21, then it needs to break. So let's go ahead and execute this. And here you can see it's printing 5, 7, 9, 11, 13, 15, 17, 19 and 21. So once it has reached the value of 21, it is leaving from the loop. Now let's say if you had to write this manually, then you just need to think. So just think about the steps. Now this loop is running for 10 times. Now if you had to write these steps manually, you need to write these two statements at least 10 times to get the corresponding updated values. And just think about it. 10 times you're writing the same set of statements. That increases the code redundancy. And apart from that also, it tends to take up more time for execution of that code.
So definitely the main purpose of having loops is to help you reduce your code redundancy and as well as increase the execution time of your code. So are you guys clear with repeat loop? Okay, so I've got a confirmation from everyone. Now let's move forward to the next loop, that is the while loop. Now while loop is quite similar to your repeat loop itself. You need to specify the conditions and it will run till the condition is fulfilled. But the major difference between your while loop and your repeat loop is that the condition which determines whether the loop has to run or not is written first in case of a while loop. So always before you begin execution of that code, what happens is that it checks whether the condition is true or not, and only then does it go forward and enter the loop condition. So if you look at the flow for the while loop, you start off with the execution, you check the condition. If at first itself the condition is found to be false, then you exit from that loop. But if it is found to be true, you go on to execute the code block and then keep on repeating until the condition is found to be false. Okay, so let's go back. And here what I'll do is I'll write the same code. Let's say while, then the condition. So here I need to mention where 3 has to be less than 21. So here we'll check where 1 has to be less than 21. Now in our earlier statement, what we had done was we were checking when the value of var 1 increases beyond 21 and then we are breaking. But here we're going to enter the loop only and only if the value of var 1 is less than 21. If that is true, then go down and I'll just copy this. So this logic is going to remain same and that's it. So I'll just update the value of var 1 equal to, let's say, 5. Select this and let's run it. Now here you can see the difference. Earlier what was happening was, even though we had achieved the value of 21, it was getting printed and then it was breaking from that loop. But in this case what is happening is that before it achieves the value of 21, it is exiting from that loop. The condition was same in both places, but it was just that how the loop statement differs. Now to give you an even better example, what I'll do is I'll just update this value, let's say 22 here, and I'll run this. Now in this case you can see 22 is getting printed. That means it has entered the loop and then it is going forward and executing this logic present inside, but only after it is executed the code is it checking the condition. So therefore with the repeat loop it executes at least once, but same thing, let's say if I modify with respect to my while loop, I'll just run this section. Here you can see nothing is getting printed. That means it's not even entering that loop. So this is how majorly your repeat and while loop differ. Your while loop is actually an entry control loop and your repeat is an exit control loop. Because your while loop defines when you enter into the loop statement and your repeat defines as to when you leave from that loop statement. Are you clear with respect to the while loop and how it's different from the repeat loop? Okay, so I've got a confirmation from Ajay, Charlie, Jude, Shweta, Aditya. It's great to see that you guys are following. Now comes the final loop, that is the for loop. And how the for loop differs from your repeat and while loop majorly is its purpose of usage. Now in a scenario where you're not sure as to how many times you need to execute the same code, you can go on to use the repeat or the while loop. But let's say you know how many times the statement written inside the loop has to get executed. In that case, you can use the for loop. For loop is a loop that you use when you know the number of times the statement has to be executed. Now if you look at the flow, what happens is you start with an initialization, that is you check the initial value, go on to check if the condition is true or not. If it is false, you exit, but if it is true, then you go on to execute the code block. Once that's done, you update your value and then go on to repeatedly check the condition. Let's go back to our RStudio and try out the for loop as well. Now let's take a simple example. Let's say I want to print the first 25 numbers. In that case, what I can do is I can say for my x, that is a variable in the range 1 to 25. That means starting from 1 till 25, just print the value of x. Okay, so if I just select this, I can go ahead and run it and you can see starting from 1, all the first 25 numbers have been printed. So since I know I need to print the first 25 numbers, I'm going with the for loop. So any doubts with respect to the three loops that we have discussed? The repeat, the while and the for loop. Any doubts with respect to them? Okay, since all of you seem to be clear with respect to the loop statements as well, let's go on to talk about the next concept, that are strings. Now, strings are basically your characters itself, but here any value that you write between a single or a double quote in R is actually treated as a string. So let me show you how to declare a string. Let me take str1 and I'll put it in single quotes. Let's say, hey, R is fun. I'll print str1 as well. Similarly, I'll just copy this and make it str2 and I'll put this inside double quotes. Now I'll select all this and I'll run this. So here you can see, even though they are written in single quotes and double quotes, they're all treated the same. Now while you are working with strings, there are certain things that you need to remember. Now one major thing that you need to remember while you're working with string is that you cannot insert a double quote within any string that is actually declared using double quotes. That is, let's say you're defining a string inside double quotes, then in between that you cannot use double quotes. Similarly, if you're working with a single quote, then you cannot put a single quote between double quotes. But at the same time, let's say you want to put a single quote between your string, then make sure it is enclosed within a double quotes. Similarly, vice versa, if you want to include a double quote, then make sure your string enclosed in a single quote. Okay, remember that. Okay, so moving forward, let's look at some of the operations that you can perform using strings. Now, let's say you want to join two strings, or better known as concatenation, then you can use the paste function. Now, let me come here, and since I have str1 and str2 already defined, I'm going to create an str3 which is going to use the paste function, and here I'll pass str1 and str2. Then let me just print str3. Now if you select this and if you run this, then you can see both strings have been concatenated and added to the new string. So this is basically how you concatenate two strings as part of R. Now apart from this, if you want to find the count of an str, you have the n character function. Now n character function is quite interesting function. Let's say n char of str3. This will give me the total number of characters present in str3. So 3 letters for hey, 1 for comma, 1 for space, that is 5, 6 for R, 7 is another space, after that you have 2 for is, that makes it 9, space is again 10, following that you have fun, which is 13. Now the first string has 13 characters, the second string will also have 13 characters, and the space between both is 1. So that means I have total 27 characters. Now let's say you want to convert the characters present in that string to uppercase and lowercase. So in that case, what I'll use is I'll use new string, string 4, which is equal to, for converting to uppercase you have 2 upper, where I'll pass my str1 and I'll create another string, that is str5, which is going to have the lowercase. So for that again you have 2 lower, so in which I'll pass my str2. Finally comes print str4 and str5. So let's execute this section. So here you can see the first string that is getting printed is completely in uppercase, the second one is completely in lowercase. In your original string you had your H capital and R capital, rest everything was small, but when you see, everything is converted into small or everything is converted into capital. But let's say you want to separate or you want to take a certain part of a string. So for that we actually have the substring option. Now let me create str6, which is going to use the substring method. So substring, where I'm going to pass my str3 as the parameter or the string from which I want to extract. Now you need to specify the position from which you want to extract this substring. So what I'll do is I'll say 5, 16. Okay.
and then I'll print str6. Let's just execute this, and you can see here from the 5th character till the 16th character, it has been extracted and stored into a different string. So any doubts with respect to strings? Okay, I've got a confirmation from Jude, Aditya, Ajay, Shweta, Charlie. That's great to see. So now moving on, let's talk about the last topic of today's session, that is functions. Now, functions are basically a block of code which can be reused with respect to different purposes, but again they help you to achieve code redundancy, and they in turn also help you to achieve different performances. Now again, if you look at the example here, let's say I want to add different values. First I want to add 3 and 5, then I want to add 6 and 9, then I want to add 1 and 5. So what happens is I need to write these statements separately. Now when I'm writing in a loop, I need to identify a certain parameter based on which the change is going to happen. But what happens if they are discrete values and I need to perform the same operation? In such cases, you can definitely go ahead and make use of a function. Now here what happens is I'm passing 3 and 5 in the first turn, that gets computed from my function and it returns me a value of 8. Similarly, next time I'm passing 6 and 9, which returns me the value of 50. Finally, I'm calling 1 and 5, which again goes on to return me the value of 6. Now, with respect to the different types of function in R, there are mainly two types. The first is predefined function, which are already present in R and we have been using them. So good example of that would be your print statement, your substring method that we have just seen, your paste method. So all these methods are already defined in R. Apart from that, a user can also go ahead and define a function. So let me show you how it is done. Let's go back to our RStudio. Let me clear everything. For every function, one of the most important part is for the function to have a name. So what I'm going to do is I'm going to write a function that's going to compute the Fibonacci series based on a value that I specify. Now my function doesn't know how many times it has to compute it, so I'm going to call the function. So the first thing you're going to start off is by naming a function, so I'll call it Fibo, then function, and here comes your parameters. So I'm going to say int a. Then open your parenthesis and then you can go on to write the logic for that function. Now here let me begin by declaring two variables, var1 which is equal to 0, I have var2 which is again equal to 1, then I'll print var1, I'll print var2 as well, and then what I'm going to do is I'm going to write a for loop where it starts where my x actually belongs in the range 1 to a that I'm getting as input, and then I'm going to create a new variable var3 which is going to be equal to var1 plus var2. Once I've computed this, I need to print var3 and then append the value of var1 and var2. So var1 becomes equal to the current value of var2 and var2 accepts the new value of var3. So any doubt with respect to this logic of Fibonacci series? Okay, so Shweta has pointed out a very good thing here. So you don't need to pass the data type with respect to that function, and this is because R actually decides what kind of data it is taking as input and functions accordingly. So we've defined the logic for the Fibonacci series. Now all we need to do is we need to call this method. So for that, just specify the name of the method, that is Fibo. You need to pass the value. Let's say I want to compute the first 5 Fibonacci elements. Then I have to just select this and let's execute it. So you can see the first 5 elements of the Fibonacci series has been called. Now let's say I need to call Fibonacci series for different values. So let's say Fibo of let's say 10, then I'm again going to call for 15. So I'm calling the function 3 times, but each time I'm passing a different value here. So what I have done is that I have generalized the same set of operations that I want for any number of values that I'm passing as the request. If you just run this, you can see for 5 it is printing the first 5 elements, then for 10 it is going on for the first 10, and for 13 it's going on for the first 13 elements. So I hope you guys have got a simple understanding as to how you can write a user-defined function in R. Now again, it is all left to you to explore it. Now you can go ahead and write functions for different purposes, and as to how you write them is completely left to you because everyone has their own personal style. So any doubts with respect to how to work with functions in R? Okay, so I've got a confirmation from everyone. So let's move forward to summarize what we've learned today. We started off by understanding how to install R. We saw the different data types, the different data operators. Then from there we moved on to understand the different conditional statements, the various loops, and finally we talked about the functions in R. So any doubts with respect to this? Since we are concluding the session, you're free to put across your questions. If not, I hope you guys have a happy weekend. Thank you.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!